Welcome back to our AI video series. Today, we're delving into the fascinating world of neural networks and deep learning. At the heart of deep learning are neural networks, inspired by the human brain, but how do they work? Let's explore. Neural networks. Neural networks consist of layers, each containing artificial neurons. There are typically three parts in a neural network: an input layer, with units representing the input fields, one or more hidden layers, and an output layer with a unit or units representing the target fields. Activation functions in neurons introduce nonlinearity, enabling neural networks to learn complex patterns. Neural networks learn by adjusting their weights and biases during training. It's a process of optimization. The units are connected with varying connection strengths. Input data are presented to the first layer, and values are propagated from each neuron to every neuron in the next layer. Eventually, a result is delivered from the output layer. Deep learning. Deep learning is a machine learning technique that teaches computers to do what comes naturally to humans: learn by example. Deep learning is a key technology behind driverless cars, enabling them to recognize a stop sign or to distinguish a pedestrian from a lamppost. It involves neural networks with many layers, allowing for exceptional complexity and accuracy. Convolutional Neural Network. CNNs are specialized for tasks like image recognition, where they excel at detecting features. Yann LeCun, director of Facebook's AI research group, is the pioneer of convolutional neural networks. He built the first convolutional neural network called LeNet in 1988. Recurrent Neural Networks. RNNs, on the other hand, handle sequential data, making them ideal for tasks like natural language processing. Recurrent neural networks recognize data's sequential characteristics and use patterns to predict the next likely scenario. Deep learning powers revolutionary applications, from autonomous vehicles to advanced medical diagnostics. Challenges that may face it by deep learning include overfitting, data scarcity, and the need for massive computational resources. Data scarcity. It is a major challenge when training deep learning models. DL demands a large amount of data to achieve exceptional performance. Unfortunately, many applications have small or inadequate data to train DL frameworks. Data scientists are always concerned about the impact of insufficient data on the performance of AI models. It is challenging to ascertain how much data is required to develop an excellent AI model with the highest possible accuracy. The volume of data needed depends on various parameters like the complexity of the problem statement, the number of categories to predict, and the algorithm used to solve the problem at hand. Data scientists use their experience and a gamut of incisive methods to determine the minimum required volume of data for AI. Overfitting. Overfitting is an undesirable machine learning behavior that occurs when the machine learning model gives accurate predictions for training data but not for new data. When data scientists use machine learning models for making predictions, they first train the model on a known dataset. Then, based on this information, the model tries to predict outcomes for new datasets. An overfit model can give inaccurate predictions and cannot perform well for all types of new data. You can prevent overfitting by diversifying and scaling your training dataset, or using some other data science strategies like early stopping, pruning, regularization, ensembling, and data augmentation. That wraps up our today's journey into neural networks and deep learning. These are the engines driving AI's most remarkable feats. For more captivating AI insights and practical tutorials, be sure to subscribe to our channel. Join us as we continue exploring the exciting world of artificial intelligence.